All right, so here comes one that you either love it or you hate it. It's called the distance formula, and it is attached to the Pythagorean theorem. Pythagorean theorem, I think most people find to be pretty straightforward. Distance formula is sort of like the younger brother. Maybe a little bit annoying, but still related to the family. Just kidding. I'm an only child. Students will be able to find the distance between 2 points in the coordinate plane. So if we want to find out how far apart these 2 points are, we can make the slope triangle like we were doing before when we were finding slope. Like if we wanted the slope of this segment, we could do rise over run. And you would look at it and you'd be like, okay, the rise is 3 and the run is 4. And then you would say the slope is 3/4. What we're trying to do is find out how long is this side, not how steep is the side. So for example, we could say a squared plus b squared equals c squared. Well, a is 3 squared, b is 4 squared, and then the side we don't know is x squared. So that would be 9 plus 16 equals x squared. 25 equals x squared. We would square root both sides because it's the inverse of squaring, and 5 equals c. We would say that that missing side is 5 units long. Now, you don't always have a picture. You don't always have a graph. So sometimes you have coordinates. This has coordinates of 2, 4. And this has coordinates of 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So we need coordinates if we don't have a picture to look at where we could say how long is this side, how long is that side, and plug it into the Pythagorean theorem. Easiest way to do this if you have the diagram is in fact the Pythagorean theorem. Now, if you don't, and you are going to look at 2 coordinates, and you want to find the distance between the 2 of them, first thing I would suggest is identifying, that the first coordinates are x and that the second coordinates are y. And that's because the distance formula uses the x and the y. The distance formula is square root. Now, why is it square root? What's the last thing when we solve the Pythagorean theorem? We take the square root. So we've got the square root, and then we need the difference between the x coordinates squared and the difference between the y coordinates squared. And you're like, whoa, where did the heck should you get that from? Well, the difference between the x coordinates is really when we said to get from 2 over to 6, the difference is 4. And the difference between the y coordinates, when you went from 4 up to 7, the difference was 3. So this is really finding that 4 across the top, and this is really finding that 3 along the side. These 2 things inside the parentheses are getting you the legs. They are squared because the formula has squared in it, right? We had to square them. And addition because we had to add them. So really you can see all of the parts are still there from the Pythagorean theorem. What we've got to do here is notice that the x coordinates are going to be part of the first section and the y coordinates are going to be part of the second. So you can always refer back to the color-coded one here if you need to. So the distance formula equals square root. So if I subtract the x coordinates, the second one minus the first one, that would be 6 minus 2 squared plus the y coordinates, the second one minus the first one squared. What do we do first when we're solving, right? Everything's on one side. We're just saying, okay, I just have to simplify the right side. 6 minus 2, because it's inside parentheses, would be 4 with the squared because we haven't used it yet. The 7 minus 3 in parentheses, which is 3 inside the parentheses, squared because we haven't used it yet. Sometimes you will get negative numbers here inside the parentheses, which is why they're there, to keep them separated from the plus sign and from the other operations. So now I need to do exponents. I'm still under that radical. 4 squared is 16 and 3 squared is 9. That should look familiar from up above. We had 9 and 16. And if I add the 9 and the 16, I still have that square root symbol. Square root of 25 is 5 units. Now, it may look like this is more work. It's actually just different work. I had to do the subtraction here on the graph. Well, okay, on the distance formula, I do the subtraction actually in the formula. The square root symbol looks really long, whereas here it was the last thing I do. Here I have it in the original equation, so it sticks around the whole time. The one thing is, if you don't have a graph, the distance formula is going to save you time and effort from creating the graph. All right, so let's take a look at some more examples that are on the back. Here's your distance formula typed up for you to reference on the back side. As it was shown before, distance formula is derived from the Pythagorean theorem, and we have x squared minus x1. Now, those are subscripts. They don't tell you to do anything. It's just saying the second x coordinate minus the first x coordinate, the second y coordinate minus the first y coordinate. When you are given a set of coordinates, you can either color code them or you can do x1, y1, x2, y2. But in the very beginning, I suggest everyone does that. I'm going to do distance equals, and I'm going to put my big radical inside my parentheses. I have to subtract the x coordinates, 5 minus 1 squared plus. I have to subtract the y coordinates, 6 minus 3 squared. And then I just start picking apart at it. Both of the parentheses inside them, I have a subtraction. That's going to be 4 squared plus, and that's going to be 3 squared. Then I do my exponents. So that's going to be 16 plus 9. And then I do my addition, that's going to be 25. And this one is also 5 units. It was not the same question, but they are the same distance apart. So here is my substitution where I plug my numbers in. First thing I did was everything inside the parentheses. Next thing I did was the exponents. Last thing I did was the addition, and then your radical. So if you need to look back at a list to keep you organized, there is one for you. So here's my x1, y1. Here's my x2, y2. Got some negatives this time, so I have to make sure I'm good with my adding and subtracting negatives. I'm going to write down my radical. I've got to subtract the x coordinates, negative 2 minus 1 squared plus, and I've got to subtract my y coordinates, negative 4 minus 5 squared. Always refer back to here. Make sure you don't forget any of the parts. Don't forget the plus sign in between. Don't forget the 2 exponents. So I've got my radical. Negative 2 minus 1 is negative 3. If I'm already down at negative 2 and I take one more away, that puts me down at negative 3. Negative 4 minus 5. If I'm already down at negative 4 and I take 5 more away, that brings me to negative 9. All right, negative 3 squared. Negative 3 times negative 3 results in a positive 9. Negative 9 times negative 9 results in a positive 81. When you get to this step, you should have no negatives left, right? Because even if you substituted in negatives or you got negatives from the subtraction, when you square a negative times a negative will always become positive. So by this step, everything should be positive. And now I've got my 9 plus 81, which is 90. And if I try to square root 90, it's not a square number, so it's going to come out approximately 9.49 units. And you'll notice I'm using units on these. I don't have centimeters, inches, feet, anything like that because they are coordinates. So they are always measured in units. Last but not least, I have another x1, y1, x2, y2, and I'm just going to start the same way I did the rest of them. I have to write my radical first. I need to subtract the x coordinates, so 9 minus 7 squared plus. I have to subtract my y coordinates, 6 minus negative 3. This is where it gets a little tricky. Don't forget your squared at the end. So 9 minus 7 squared is just 2 squared. No big deal. Plus 6 minus negative 3. So 6 minus a negative 3 would be the same as 6 plus a positive 3. Minus a negative plus a positive, and that's 9. So this is going to be 9 squared. 2 squared is 4. 9 squared is 81. And if I add those together, I get not a square number, but that's okay. If I try to square root 85, I get approximately 9.22 units. And I'm done. But don't forget, you do have to be careful, slow yourself down a little bit when you're adding and subtracting negatives.